Then how to construct the trees? Now for example, if you have hundreds of sequences, right, and how to construct the trees. So there are various ways, there are several ways to construct the trees. So one of the foremost methods and the popular methods is UPGMA. This is unweighted pair group with arithmetic mean, right. This is why they simplified as UPGMA method. It is very common method and you can easily understand how to construct the trees using UPGMA method. It has a good understanding, but it has some issues, some disadvantages. So rectify that one. There are several other methods have been proposed. There is transform distance method, neighbors relation method, neighbor joining method, maximum likelihood approaches and so on. So they developed several approaches to construct trees. So we will see how to construct trees based on UPGMA and what are the principles used in the other types of methods. So it is a statistical based method, right. So it requires the data to be connected or to be condensed to a genetic distance. For example, we can use DNA sequences or you can see protein sequences. So they look at these sequences and see how they are different from each other. They calculate the distance, right. It is a statistically based method. They use the statistics to analyze the data to construct the trees based on the distance. So how do you think about the distance here? In this case we have we know the only the sequences A, C, C, T, G. This is for example sequence number 1. You can sequence number 2, you can see A, G, C, A, G. So how do you calculate the distance between these two? It is in the 2 dimensional case, this is not the 3 dimensional one. So in this case if you see how far they are different from each other. So how far A is different from each other? So what is the difference? How many nucleotides are different? This is same, this is different, this is same, this is different, this is same. So here you can see the distance is 2, distance difference between A and B are 1 and 2, 1 comma 2 that is equal to 2. So for example, if you take the species A, B, C, D, E, 4 species, right, you put A, B, C, okay, B, C, D. So you calculate the distance between A and B, let us put DAB, and A and C is DAC and A and D is AD, right. This is same because B and B are the same, so there is 0 and B and C already we include here, right. So this way they put dash here, likewise B and C you can get here, B and D and C and D. So they get the distance among all possibilities. Among the all possibilities you can get the number of mismatching sites, from this which two are close to each other? The one with less number of mismatching, right. So we will show some examples and if then they are related. For example, if A and B are, this is the closest one for example, then you can say they are very close, they have the similarities, they are close to each other and then you can combine this group with C and D. They use this equation to combine AB with C, they take the AC plus BC by 2 because this is C they have to combine. So this is C is common because A and B they have to combine. So take this A and this B and take the average, so then we will get the AB into C. Likewise you can do AB with D, right. So you can see A with D and B with D, right, and take the average, so you get the ABD. Now you can see the smallest ones, then see which two are close to each other. Likewise construct for everything and based on the number information, based on the smallest distance we can construct a tree. So now here these 5 sequences A, B, C, D, E, right. These are DNA sequences for the 5 species A, B, C, D and E. Now we need to construct a tree. Which parameter we have to calculate? Distance. So how many distance you have to calculate? Distance between
all possible
A and B, A and C, A and D, A and E, likewise BC, BD, BE, CD and CE, right, all the possibilities, right, AB, BC, AC, okay, AC, AD, AE, BC, BD, BE, CD, CE and D. We get the numbers. From this number, which one or which pair is close to each other?
that will
based on the distance, right. For example, if it A and B, so we take the sequence A and B, right, compare these two sequences and you can see number of mismatches, right, how many number of mismatches, right. So, how many mismatches between A and B? 9. Okay, I put 9. So, if you see this, you can make this matrix A, B, C, D and here B, C, D, E because 5 organisms. So, A and B there are 9, likewise A and C mismatch is 8 and A and D is 12, A and E is 15. So, like B C, B D, B E and C D and C E, right, and D E. So, between the D and E, if you see D and E, so there are 5 mismatches 1, 2, 3, 4, 5. So, first 5 mismatches. So, this is the closest, this is the lowest value. So, from this what can we infer? D and E are close to each other among all the combinations. This has the very low, the lowest number of mismatch. So, you can see D and E are close to each other. So, you put the D is here, E is here and they are close to each other. We make first branch we can make and first node also we can make. This is the common node. So, D and E are close to each other. Now, what to do? You combine this D E with all other species A, B and C. So, how to do this? You take the average, right. For example, if you see B and A, we do not make any changes because we need to combine D and E. So, here we put the 9 as it is and we put the C, right, and the D and D we have to calculate because B and C we do not touch. So, if we take the D and D 12 plus 15, what is the average?
13.5.
13.5, right, with respect to A, and D and E with respect to B
16.5.
16.5 and here 11.5, right, because we combine this D and E with respect to A, with respect to B and with respect to C. So, now I get this matrix. From this matrix, which one is the lowest number? 8 is the lowest one. We have numbers 9, 8, 11, 13.5, 16.5 and 11.5. From this 8 is the lowest. So, what do we infer from this one? A and C are close to each other, right. So, you can see A and C are close to each other. Earlier we did this is D, this is E. Now, from here we can see A and C are close to each other. Then what next, what we have to do? We have to combine this AC with others. So, you put the AC here and the B and AC, D. Now, we have 3 B, AC and D because A and C already merged, D merged already, then B is there. So, you have the B, AC and D. So, combine this AC with B, right, AC with B, this is equal to 10 because 9 plus 11 equal to 20, right, A plus B C, right. So, 10 by 2 this is equal to 10. Then with the D to E, so 12.5 and 16.5. If you see here, this is with A, we will combine A and C. So, take the average 13.5 and 11.5. So, this will be 12.5. Here we will not touch because with the B, because we are doing with AC. So, here this is equal to 6.5. So, from this matrix, now we constructed the next matrix. From this, which is the lowest one? 10 is the lowest one. So, AC with the B. So, we have the AC here, common AC, right. With the AC, we can connect with the B, right. You can go with this one. If you put like this, then you can see all the 3 are the same line. This way, you put this line and then this is related with the B. And then if this is out, then these 2 will be the remaining. So, then DE and AC, the DE and AC are common to each other, finally you get the tree. So, from this one now we can construct a tree, right. D and E are close to each other, E and C are close to each other and this AC is close to B and this is close to D and E. So, we can construct this graph. So, when you have this graph, now we can easily tell. So, what organisms they are close to each other. The next question is how long it takes to evolve from one to other. So, we have a time frame. So, can we able to estimate the time, right, because we have some numbers. These numbers tell the number of mismatches. So, with the number of mismatches, you can see very less mismatches, it took less time. If more number of mismatches, it takes time, right, to go from one organism to other organism. So, now okay, now we see the length of the branches, we can calculate from the distance matrix. So, how to calculate? this is the pairwise comparison. We construct the matrix, right. This matrix is same as the one we derived here, this one, right, the same matrix. Now this is E and D is 5, we assume they evolve the same time. If this branch is 5, then we divide this to 2, so each one will get 2.5. If it is D is here and the E is here, this will take 2.5 and this will take 2.5. So, made this, okay, this is 2.5 and here this 2.5. Now, the next one, if you take AC equal to 8. So, if you can draw this A and C, this equal to 8, you divide into 2, so you put 4 and 4, 8. Then AC with B, right, AC with B, what is how much, what is AC with B? It is 10. So, already here we put 4 and 4, 8. So, the remaining 2 we give here for the B. So, total will be 10, then AC with B equal to 10. And then totally if you see the A to E, right, this is 15. So, we give this is 2.5, here the rest we put here, this is 12.5 plus 2.5, this equal to 15. So, made these numbers, then you, from this you can tell this evolved first because it is very close, then this will takes 4 and here it takes 6.5 from AC to DE, right. From this you can estimate the time approximately from one organism to other organisms. This is the method you can easily construct trees, right, with simple statistics. So, what is the principle used in this UPGMA method? Distance between the two sequences, how far they are different, based on that we can construct a tree. So, this is another method, this is called neighbor relation method. Here also it is similar to UPGMA method, but this is a unrooted tree, right, and you can see in the UPGMA method sometimes the number is not equal. For example, if you go from here to here, if you add up these numbers as well as if you add the values here, for example, A to E, this is 15, but A to E if you add from here to here, you will give the different number. In this case it is not able to exactly account some numbers. So, for that one to make a correction in this method, they put few more conditions, right. They try to join all the neighbors, not just join one by one, they try to join different numbers and see the closest one, which one is the minimum. So, they use that criteria to develop these methods. How to do this? It is an unrooted tree. So, A here, B here, C and D. So, here from A to B and C to D, this is not equal as A to C and B to D. So, added another line between these two, that is E. For example, here this length is A and this length is B and this length is C and this length is D, and they put additional length as E. So, if you see AC plus BD, this one and this one, right, this is similar to AD plus BC, we can give as A plus B plus C plus D plus 2E. That means AB plus CD and 2E, and here you can see the discrepancy between this UPGMA method and this method, they considered this also into account. So, because of that, this is the value you get from the UPGMA method. So, if you add up AE 19, but actual case it is 15, because this is missing. To take care of these conditions, they made a 4-point conditions. If you put AB plus CD, that should be less than AC plus BD, right, because if you see here AB plus CD, that should be less than AC plus BD, because we have this value E, as well as AB plus CD, this is also less than AD plus BC, right, here either we take this or you take this, right, that should be less. Okay, now if you have different species, they consider all the pairwise arrangements and put in such a way that they should satisfy this 4-point condition, right. Now, I have this one, okay, for example, 4 species, we have different values, you can calculate AB plus CD and AC plus BD and AD plus BC, and the smallest sum which can come close to each other, that is 1 and others put 0. Then we repeat for all possible pairs and take the closest ones, ones with the highest score are grouped, and then from that groups you can calculate the UGPMA method to get the distance. Then along with the UPGMA method, they considered special conditions to derive these trees, right. There is another method that is called neighbor joining method. In this case, instead of going one by one, they make a star like tree. So, each species is connected and then see how far they can connect with each other regardless of this any of these numbers. So, the difference with other methods, here you can see the sum of the branch lengths with each iteration process, because we consider each one separately and finally they try to see how which one has the closest distance. Based on that they derive this equation, okay, it is a complicated equation depending upon the distance, to get what are the possible pairs which is connected to each other with respect to the smallest distance. Once the smallest distance could find, then they can use this standard method to get the distance matrix as well as to get the trees. The simplest one is they try to utilize the information from different species together than doing one by one. Then recently they developed another method, right. Whatever we use the EGPA method, we considered all the nucleotides, all the amino acids with equal weightage, right, because what is the value number we use from UPGMA method? The distance. So, it is AT, A is changed to T or A is changed to C or A is changed to G, we take this one because we take only the mismatches. So, in the maximum likelihood method, these are the statistically based method, but they give weightage. For example, in the case of nucleotides, right, what are the weightage they give usually? Purine to purine, and pyrimidine to pyrimidine, right, they give some weightages, and this is transitions. In the transversions, what transversion? Purine to pyrimidine or vice versa. In this case, we give more penalty, right. So, in the maximum likelihood method, they try to give weightage to transitions and transversions. Likewise, if you take the amino acids, when you construct trees, right, they also use some sort of information. For example, they can use a popular matrix, which matrix? Pa matrix or Blossom matrix. So, you can see the similarities. Also, they can also design a matrix, right, based on the physicochemical properties or the molecular weight, right, size. So, if you have the misalignment, the alignment with the mismatches, see similar residues or completely different residues, they give weightage. Accordingly, they can also develop a tree, develop trees, right. So, different ways to construct phylogenetic trees. So, in this case, if there are multiple substitutions, right, may be independent or sometimes independent, right, that also we can take into consideration, right. But to take all these aspects requires high computational power, but the current facilities it is possible to use all the information. There is a reason initially they tried to develop a method with the simplest possible, that is the UPGMA method, and with the availability of computational power they try to increase the complexities, right. So, that we can, if you increase the complexity you can get better performance, but performance you need to sacrifice in terms of time, right. If you have more time, you can add more time to analyze and you will get better results. So, now it is possible to construct trees by considering all these aspects. If you look into the literature, there are so many methods available, okay, here I list up a set of methods. So, Phylip is one of the most popular methods, even currently it is a widely accepted method, right, for constructing trees, and it will take few minutes to just demonstrate the functioning of this Phylip, how to do this. It is a program for constructing a phylogenetic tree for any given set of sequences. If you get the DNA sequences or amino acid sequences, it will create the phylogenetic tree. So, construct a phylogenetic tree. So, what is the input they require? In this case, we take the multiple sequence alignment. We need at least 3 sequences. We take the sequences and make the alignment, right, and use the alignment as input for constructing tree. How to get the multiple sequence alignment? What are the methods commonly available to align the sequences using multiple sequence alignment? Cluster W, currently cluster omega, right, mapped, promols, puzzle and so on, right. So, Phylip automatically gets the information from mapped. If you give the mapped alignment, it will automatically take the alignment and then give you the tree. It is very easy. So, it is widely used to prepare the input file suitable for Phylip. If you use mapped, there is an option to save the file in Phylip format. So, you do not have to worry about the formatting. Run mapped, save the multiple sequence alignment in phylip format and you can give this as input to run phylip. So, this is the home page for mapped, right. So, they have a download version as well as online version. You can go to this website and then you can access mapped. If you like to use the online version, just you go to the online version and give your sequence. Okay, these are your sequences, but it will create your multiple sequence alignment, right. So, if you do this, it will ask for the conditions for the parameters, which parameters you want, right. With aligned one, you need the aligned ones. So, we need the aligned one, you click here, right, and this amino acid sequence. Also here this is recommended if that less than 2200 sequences, right. We click that one. Depending upon your sequences and the refined data you need, you can choose any of these settings. If you do this, so now you can submit the data, right. It is asking for this alignment and the plot, right. So, you ask for the matrix. So, we can use the blossom matrix, right. So, when if you click on submit, so you will get the result. This is a multiple sequence alignment. Now, the question is, okay, whether you need to reformat this or not, right. Do you want to reformat it? Yes, because we want to use this for phylip, right. So, you have a reformat option here, right, and you can use different formatting. So, if you want phylip, we can use phylip. Currently, mapped also includes to construct trees directly, that is also possible, but if you use phylip, you format with the phylip format. So, we do this, right. They will ask for the which phylip version you want. Based on the version, if you submit, then you can save the file. This is the phylip format, right. This is different from the map format. So, these are the your sequences, they are aligned for the phylip, right, and you can save this, right. You can download the file, right, you can save the file now. So, you have the input file for phylip now. Now, next one is you need to run phylip to construct the trees. So, to run any of these programs and if to check whether your results are significant or not. For example, if you give 10 sequences, it will construct a tree, right, and what will happen if there is a change, right, whether the program depends upon these sequences or also this different from the new set of sequences or completely randomized sequences, because you have 10 sequences you will get a tree. If you completely randomize a sequence, there also you get a tree, right. Your tree is the same as randomized tree or it is unique for your sequences. If it is unique, then what will you infer? Very significant, because you will get a unique tree. So, that is good for only your sequences. If your tree and the randomized tree are the same, then what will you infer? It is not same, because it could be possible by random, not exactly 1 and 2 are close to each other. Even if you take any random sequences, 1 and 2 will be close to each other, right. For this case, they use a method called bootstrapping to increase the confidence level, whether your tree is confident or not. So, in statistics, this is a computer based method to assess the measure of accuracy for any analysis. So, what to do? This is the practice of estimating the properties of the estimator, because here we want to have the proper alignment such as its variance and so on from the sampling of independent data, right. You can have several independent data, right, and from the sampling you see whether your data is significant or not. How to do this? So, you do various empirical distribution. For example, you can resample, you construct large number of resampling, for example 100 times, 1000 times, 10,000 times you can resample the data, and from this sample you construct the trees and compare. For example, if you have 10 sequences, if you align, you will get 10. Each sequence you can sample many times, 100 times, 1000 you can take. Then from the pool you take any 10 and then again you construct. Do it for 1000 times and 10,000 times and then see how many times you get the same two sequences that are aligned together, right. If it is completely random, you do not get any random distribution. If two are really close related, then always you get these close to each other. I will show you how to do this. So, in this case, first we have to do the bootstrapping. So, there is the here you can, when you download phylip and when you install phylip, you will get all these files. So, one is the bootstrapping method here. This is your input file work one, you saved in the previous one. So, you get bootstrapping, right, it will ask for the input. So, how many replicates do you want? Because you have 10 sequences, how many replicates you need to get for each sequence in 100 or 10,000, 1000 anything you write, right. If you want also it ask for the different options. So, you have they give any weight or any characters, or you can see the sequences which type of settings you want, bootstrap or jackknife or whatever, right. Here you put the bootstrap. So, what the sampling procedure do you want, right, is the regular sampling procedure, and here replicates, right. If you want to accept you put y, but if you want to change just you can change, right. If you have y to accept, right, and type the letter for one to change, any letter you can change. If you want to change the replicates you put r, right, then you can you put r, then you have changed the number of replicates. Whatever you want to change put this letter, then accordingly you can change, fine. So, if you change the replicates it accepts, right, then they ask for random seed, that is for the programming purpose, right, and finally it will get, if you put 10 replicates it generates 10 replicates, okay, then the output is written in this file, right. Okay, you can see this. Now, the out file, if you open the out file it contains 10 replications, okay. So, here you can see 10 replicates, right, the out file contains 10 different sets of each of your sequences, right. Now, you have to use the method. Now, you have the bootstrap, for the bootstrapping you did the sampling and you get lot of replicates. Now, there are different ways to get the tree, right. So, one is the maximum likelihood, this is the one which considers the substitutions. So, this is the promol, this is the program which can run for the maximum likelihood method. So, go with this one. So, the out file you obtain from the bootstrapping, this can be the input to the promol. So, you do not have to do anything. So, run this one giving the input as this out file. So, you can see this out file as input, then you can write the file name which one we need to save. So, you give the file name, right, then again they ask for the same question whether you want to change anything. If you do not want to change just you put y. So, if you want to change you can give the letters appropriately and you can change. How many times you want to jumble this sequence again, right. So, you can also do that, and finally you can get these things, okay. They got the trees and they wrote in this out tree, this output we can see here, right, file it is saved. Okay, now, you can have the tree and you can view the tree using this program called tree view, right, this you can work with this window system. So, you go to tree view, open it, okay, then open the file, you go to the open here, right, and here open this file name here, out tree is a file name. If you open this you will get the trees. So, you have 10 different cases. So, you can see the trees. So, this means which two are close to each other, say these two are close to each other and these two are close to each other, these two are close to each other, these two are close to each other, and these two and these two are again this is close to each other, this line, right. So, you can see the linearity between among these different sequences. Now, the question is how far you are confident that these two are close to each other. So, for this case you can go to the consensus tree, right. So, go with this work on consensus, this is your file. So, finally, if you give the files, right, finally you can get this file work on consensus, right. Now, if you get the tree, this OASL tree, so here is the option called rectangular cladogram. If you click on that, then you will get this with the numbers. So, from this one you can, what is the meaning of these different numbers, right, what is the significance? If this is a 10, we got 10 options, out of 10 all the 10 these two are aligned to each other. In this case between these two, okay, the possibility is only 50%, between these two the possibility is 100%. So, he is more confident that these two are close to each other compared with these two are close to each other. Likewise, you have the numbers, this will tell you the closest sequences as well as how confident you can see that these two sequences are close to each other. So, in summarize, what did we discuss in this class? Construct your trees. What is the meaning of tree? It will give you the information regarding, right, the relationship among the different sequences and how far the time taken to evolve from one organism to different organisms, right. There are different ways to construct the trees. What is the most common method, right, UPGMA method, right. What is the input for the UPGMA method? Sequences, which information they obtain from the sequence? Distance, right, they take the mismatches and use the mismatches they will construct trees. There are a lot of other methods also available for constructing trees, right, and the maximum likelihood method is one of the most widely used methods because that uses the information regarding the characteristic of nucleotides or amino acids. What is the program we discussed to construct trees? Phylip, right? What is input for the phylip? Multiple sequence alignment. You can use map to get multiple sequence alignment, right? And then you can construct the trees, right? And you can also validate using bootstrapping method, right? Fine, right? So far we discussed various aspects, for example, the sequence alignment, conservation, and the trees, and so on. Next classes we will discuss about the different parameters or different properties or different features which can be derived from the amino acid sequences, and how these features or the properties will be useful to understand the structure and function. Thank you very much.